Okay, in today's video we're going to look at the internal structure of data sets, and we're going to use build dataset to help us do that. So we'll double click into the data manager, right click, dataset, and add build dataset. Now I'm going to get my desktop set up, so we'll split the views, and this one I'm going to change my properties to object tree, and you'll use that in a second. We get a properties editor and a property editor, and I think I'm going to dock them over this way. And finally we'll just get the data view up here. Okay, so we're going to start by looking at the first predefined data set on the builder, and that's the A-scan. We'll run that. Click on there, it shows up there. And now I'm going to drag this onto this viewer here, the one we set up as the object view, and you can see the internal structure. So each of these nodes has an internal structure of objects that help define the data that it's holding. And in this case, we've got a data subset, and its role is it's the object that actually physically holds the memory. And we've got an element, and that object is an object that describes the each element, each point in the data. And this is an axis, and we've got one of them, so it's a one-dimensional array, 2,000 points, and some description of the axes. So what we end up here is if we do our tooltip on the data subset up there, you can see that the element is telling us it's minus 100 to 100% in floating point elements, and the axis goes from 12 to 32 in steps of, well, 10 nanoseconds. And that's our data structure, and you can see it gives us a waveform down here. Okay, so we'll continue on, and we'll do our next predefined task, the B-scan. And you can see that more structure is shown up here. And we've got the axis, which is actually the same as on the A-scan, so that's the same. The element is the same, 100% floating point. And we've got this other axis up here. And this one is in millimeters, and it goes from 10 for 123 points, and we can hover over the data set, and we can see that it's 10 to 22.3 points, 0.1 millimeter step. And the thing to realize here is that the data axis is living on the subset. So I'm going to scope out, and you can see that its parent object is the data set. In this case, the parent object is the data subset. I'm going to scope back in, and the meaning of that is that this axis here will apply to all the subsets. This axis here applies only to its parent. And in the order of the axes, the ones that are universal come later. So you can see that that's axis 2. Okay, so let's continue on to our next predefined is a C-scan. And this one, we've got two data subsets. They each have a data element. And the elements are the same in this case. They don't have to be. The element lives on the subset, so that tells you it applies to it. And we've got two axes on the data set, which means they're common to all subsets. And if we look at this, we'll just look at the number of points, 123 by 87. And if we hover on the subset, 123 by 87 points. 123 by 87. Okay, so this would, and physically when you're collecting data in an ultrasound tank, a scanning tank, these would represent the motion axes, which sort of explains why they're common. So if you have axes that go in a raster scan, they're going to be the same for each bit of data you're collecting, but the bit of the data may be, say if they're a waveform, will have their own independent axes. So it's physically meaningful if you think about it in that way, that these sort of represent spatial motion and these represent the measurement that's being captured, say a waveform from an ultrasound probe or an eddy current signal, or some sort of signal that it has physical meaning. Okay, so we will continue on down, and next is a waveform scan. So this one is similar to the last one. We've got two axes on the data set, so again, those probably, they don't necessarily, but typically would represent physical motion. And this would represent, this axis represents the measurement that's being collected. And you can see here, that one is off screen. You can see as I go, I can drive through the out of plane axis, which in this case would be the third axis. And so we've got the first axis, the waveform, the second axis, the first motion axis, and then this one is the out of plane, the second motion axis, the third data axis. Okay. And finally, let's go on to a phased array sweep. And we'll run that one. And in this case, what's happening here is the probe is pulsing multiple times and we're getting multiple waveforms. So as you might be expecting, you're getting one axis that represents each waveform going and coming back, and then the second axis is the number of waveforms. So in this case we have 30 waveforms. And because that is to do with the measurement that the ultrasound pulsar is sending out, these all live on the subset because they're to do with the measurement. They're not to do with the motion. And as I carry on here, I'm going to do a add one-dimensional motion to this. And I have to run that. And now you've got some other objects sitting in here. It's good to know these are here, but we're looking at our axes and our elements. So this is our motion axis, living common with everything that's being collected. In this case, it's only one sample or one measurement that we're making, but that measurement is a 2D array, so an image essentially. And I'll just bring that up there, and I can pin that. And so you've got your three axes here. The waveform axis, the A-scan axis is that one. The sweep axis, that's going across, recording for each waveform. And then this one records each scan position. And I think that's sort of a good representation. This is the same thing with complex data, so I don't think that gets us any further. So I think we'll leave that there, but that gives you hopefully a better sense of the internal structure, the axis, the subset is the array, this object, the data element, describes what each sample point represents, and these are the axes of your array. So starting in here, the first axis, second axis, and then out to the data set, the third axis. Okay, so I think in our next video we'll look a little more in detail of what the build data set is doing.